Hello. In this video, we're going to talk about a concept known as classes. And with classes, we also have a concept known as objects. So a class allows you to create your own data structure. We know about data structures already, like dictionaries, lists, strings. We also have integers and those kind of things. There's all different data types and data structures. But a class lets you define your own data structure and what kinds of things are allowed to be done with that data structure. So let's imagine we're going to define a rectangle, what it means to be a rectangle. We start by saying you've got a class called rectangle, and you put a colon after it. We usually capitalize the name of a class. Now, I want to start by not really doing anything special to define a rectangle, so I'll just put a message in here. This is a rectangle. So this class definition doesn't really have any content, but we'll expand on that. When you run it, really nothing happens. What this allows you to do, however, is actually make an object of this type. So A will be a rectangle. This is how you create an object. So I'll make a comment here. So A is just a regular variable. However, it's not an integer, it's not a string, it's not a dictionary, and so forth. It's a rectangle. I've defined my own type. And when you make a new, we call it an instance of a class like this, you're making an object of that class, also called an instance. So the class really says all rectangles behave like this. But then when you go and define an actual rectangle like this, A is an actual rectangle, so A is an object of that class. It's kind of like saying you can define what a chair looks like generally speaking, chairs have four legs and a back and a seat and so forth. And then you can say, I have four chairs. These are individual chairs. They all look a little bit different, but they're all still defined as chairs. So these four are four objects, and the concept of a chair is the class, like what defines a chair. When you print an object like this, you'll see it just says, I'm an object, and it has a location in memory. Doesn't really matter to us, but it just says, I'm a rectangle. Now, all classes allow you to add fields to them, or properties. It goes by a bunch of different names: fields, properties, variables, and so forth. Let's say that rectangles have a width. So I can say with dot, I'm going to define a width inside of A. And when you run this, actually nothing interesting is going to happen. What if I were to print A? You'll see that it just prints the same thing. I'm an object at this location. So it's the same A, even though I've added something to it. And if you want to get that width, you can go A.width, print that. There's the 5. Now suppose I make a second rectangle. And I try to print the width of that rectangle. You see, first of all, it is a second object. It's in a different location. And it doesn't have a width. It's called an attribute here. Field, property, attribute, and so forth. So A has a width, but B doesn't, even though they're both rectangles. And this shows I'm not really using the class to, what kind of advantage I can use the class to, because all I'm really getting right now is the fact that it's called a rectangle. That doesn't really do a whole lot. I'm not even confident that all the different rectangles I create are going to have widths and heights and so forth. So what would be better, instead of just this message, which doesn't really do anything, is to define what it means to be a rectangle. So we're going to say what happens when you make a new one. And what we're going to say is when you make a new rectangle, you automatically have a width. And the way we do that is we actually put a function inside the class. This is a special function. It has a very special name, and you have to type it exactly like this. It's 2 underscores, which is shift and then minus sign. The word init, which means initialize, and then it's a function, so it needs to have parentheses, And we could just say it has no inputs. What it means to be a rectangle means you have to establish that you have a width and a height. Actually, I forgot. There is one thing that needs to go in there. It's called self. We're going to use self quite a bit with classes. Self is a variable that lets you refer back to yourself. What that means is the class will be able to refer to its own data. So all rectangles, whoops, not X, will have a width and a height that starts at 0. And then you can change it later, but at least you know it will have a width and a height. So now what's happening, when this command executes, it really does run this. I'll put a print in here to show that it's running. And I'll print what the self value is. So it runs the init every time you make a new rectangle. So that means you're allowed to change the width, but at least every rectangle will have a width and a height, even if it's just 0. So that's the message running init for self on this first one with A. You see that self, actually this is all of self, that's the same thing that A is. See how it's 0x10CFC4110? That's the same thing as A, where I print A twice. So in the init, this function executes when you create a new object of your class, and the variable given to the function is the object that it's creating. So this is like saying a.width and a.height. Except inside of here it doesn't know it's called A, so that's why they use a thing called self. And also notice that function ran the second time for B, and when you print B you see it's the same. Self is the same thing as B. And B's width is going to be 0. It doesn't crash anymore. This means every rectangle has a width and a height. So I've essentially defined a new type of data, kind of like a dictionary. There's a width key and a height key, basically. But I get to call this thing a rectangle instead of having to call it a dictionary or whatever. And I can go even further and define things like area that only makes sense for rectangle. If I go and make a circle class, I would have to make the area function different, for example. I'm going to remove this print because that's not really something I would keep. Let's run that again. All right, so every rectangle has a width and height. Now, you could just stop at this point and say, well, that's great. I can print the width, I can set the width, and so forth. And that sort of helps me save some time because at least I know everything has a width and height to start with. But more useful would be to not have to set the width and height as a second step. What if you do it at the time of making the rectangle? So we can define another version of init, which still says self because you always have to have that. And then suppose you get to provide the initial width and height at the time of creation. So it's still init, but this time if I put these two extra arguments, they'll be W and H. It'll use this version. See how B's width is now 10. And this line I don't even need, really, because I do it right there. So let's change it to that. So A's width is 5 and B's width is 10. You still have the option of not using that version because I've left the other version there where it sets them both to 0. Oh, actually, no, because I've redefined it, I don't get to use that version anymore. So let's undo that. And since we've defined this version, it was overriding the other version. So this is the only version you get to use. Okay. So we've defined that a rectangle, when it's created, it has to be provided the width and the height. And when you do provide that, it sets these internal properties called .width and .height to whatever values you gave. And then you can change those values if you want. after you've created the object. Now, notice it's kind of interesting how you provide 5 and 3, but in fact, when you define the function for what's supposed to happen, it actually has 3 arguments. The 5 and the 3 are the last two. The self is always going to be there. It's hidden when you use it, but when you define what happens for this init function, self has to be there because it's going to run init after creating the object, basically. We saw that when it printed the same object for self as for A, and then the same object for self as for B. So when you run this kind of function, when you create an object, it creates it first and then runs it through this function. And these steps allow you to save what was provided at the time of creation. Now, I could define an area method where I take a rectangle object and I say the definition of area. So then I can say print B's area is, and then I can pass in area of B. And since it returns the multiplication, it should print it. B's area is 100 because it's 10 by 10 times 10. So that's kind of nice in the sense of you give it an object and it takes one parameter. You don't need to give this area method both a width and a height. It can look inside the object and get the width and the height. But since you might have different kinds of shapes like rectangle and circle, it would be even better to put this inside of the class, because really this definition only really matters for rectangles. So let's incorporate this definition into the rectangle class. So you define it inside the class. It's inside because it's indented. And you don't need to give it the rectangle in question. It would be self. And then you would say self.width and self.height. So this class rectangle has now 2 functions inside, or 2 methods. One is what happens when you create a new rectangle at this stage. And then this other function can take an existing rectangle and give you back its area. The way that would be used now is not like this anymore, because we don't really have a function called area that's defined separately. Now it's really the area of B itself, and it really has no inputs anymore. The self input happens automatically because you're running it on the B object. Self will be the same thing as this B variable. And if I run it on A, self will be the A variable. A's area is 100, B's area is 100. Now A's area is 100 because it's 5 times 20. So I'm going to take these parts out and leave the parts that I would just normally do. So this is kind of code I would normally do. I'd say, let's make a new rectangle of 5 by 3, and then we can compute and print its area, make a new rectangle of 10 by 10, and compute and print its area. So it's the same area function. It's just if you use it on A or you use it on B, that changes what self equals. Self would be either A or B. And when it's A, self.width would be A's width, and so forth. A's area is 15, B's area is 100. Now you can go further. You can, I don't know what else you would do here. Maybe you can make a list or something. And you can put all different kinds of data inside your class. You can have a thing that's a dictionary or whatever. So at this point, really anything goes. You can find a lot more methods, but this is the basic structure. So when you define a class, you're pretty much always going to have an init function that has to be written exactly like this. This is the function that executes when you make a new variable of that class. You may or may not have some arguments. If you do, you got to list them after self. Self is always going to refer to the thing that it's actually creating, the object. And so you can use this self to establish some data for your class. And you can define more methods that use self. Basically, any method in the class should probably use self, otherwise it's not going to be super useful. And when you use the method that's defined in the class and the method has a self, you can use it like this, where you put your variable first or your object first, and then you use the name of the method. Now, as you'll see in the book, chapters 15 and 17, I think it was, you can define methods that don't use self, like and then you can do whatever. So here's the method that has no inputs, not even self. It's inside the class technically, but the way I have to use this, well, first of all, just show that it's happy about that. So it doesn't care that we've done that. But if I want to use it, I can't say b.testMethod. In other words, I can't run test method for b specifically, because when I do it like that, it expects that there was a self here, but there's no self here. So the only way to run this method is to run it from rectangle directly. And so it does run. It says this is a test. But that's not often all that useful. Sometimes you want to put methods inside a class just so that you kind of group them together, because they all now have to start with the word rectangle. But if you don't use self, you're not really getting access to any of the data that's been set up for the class. Like, I can't get B's width, I can't get A's height if I don't use self. If I turn it into self, well, now I can't actually use it this way because it doesn't know what to make self equal to. So I can say a.testMethod, that would make self equal to A. And b.testMethod makes self equal to B. Doesn't really matter because all the thing does is print a message, but that's the difference. You'll see in the book they do define some methods without self, but it limits the way that you can use them, and you can't access any of the data for these objects. So pretty much every method you're going to put inside a class will be a method with the word self, because almost always your method should use some data from the class. You might even think of a case like this where you can refer to one of your other methods. So you can make a method that uses self and then refer to one of the other methods that also uses self. So here I can say b.print. My area is 100. So b.print ran this with self equal to b. And so this really said b.area, which ran this with self equal to b. So this really said return b times width times, or b.width times b.height. All right, so self is a placeholder for whichever thing is doing the method, whichever object is running the method. All right, so that's classes. That should basically give you enough to complete the assignment. The assignment here, assignment 8, says, let me increase this. You need to make this code functional. So right here is where you should define a class called album. You know it's called album because you see it used here. So notice this is kind of like our rectangle, width and height. There are 3 things being provided: 2 strings and an integer. So you want to save those in your init method. This function call just goes up here, so that's not special. But notice here, after you get a float for the rating, like a score, you need to define a method called addRating that takes that float and puts it in a list of ratings. So this needs to be a class method. And notice how it's being used. It's being used on an object, so this needs to have a class method with the word self in it, plus the rating. And then there needs to be a print method, kind of like I just showed with the rectangle. And I think that's pretty much it. And the print method will do whatever is necessary to compute these kind of things. It should print like this. Now notice we're using Pickle again. One of the cool things about Pickle is it can handle classes just fine. So Pickle can handle lists, dictionaries, and so forth, and it knows what to do about classes. All right, if you have any questions, put it on Discord or email me, and that's it for now.